Good afternoon, everyone. Hope everyone's having a wonderful time here at Ignite in beautiful city of Chicago. My wife used to live in Chicago, so I actually brought my wife with me on this business trip. So hopefully the weather will stay nice so we get to enjoy the weekend here. So my name is John Lee. I'm responsible for the AI infrastructure and VM product team at Microsoft Azure. So our team is responsible for defining the roadmap and the execution of the product strategy that runs all of the Copilot services on Azure today. So I'm super excited to share with you our vision and where we're going with AI supercomputing for both AI training as well as inferencing. I always like to start these presentations with a little bit of a trivia just to kind of get our brains going a little bit. So I have an interesting trivia question here for you. So what do these three things have in common? Crayons, Moore's Law, and Goose from Top Gun. Anyone? Anyone have a wild guess? Okay. It was a little bit of a stretch, but these are the three iconic companies that I've worked for or had the fortune of working for in my career. So crayon is an affectionate term that everybody inside Cray calls one another. Our president and CEO, Pete Ungaro, used to say, once a crayon, always a crayon. By show of hands, by chance, anybody here worked at Cray before? Okay, no problem. So I started my career in Cray, and then I moved over to Intel. I worked there for about 7 years. I worked for a lady named Trish Damkroger, who's currently the Senior VP at HPE, responsible for all the HPC and supercomputing and mission-critical systems. And the last program that I worked with at Intel was the Argonne's Aurora supercomputer, which is the second exascale class machine in the world. And now, for the past 2.5 years, I've been at Microsoft, and I've been in the middle of this whirlwind craziness that's been going on ever since the launch of ChatGPT. So this is what I mean by a little bit of a stretch, because Goose from Top Gun is the co-pilot for Maverick, Tom Cruise, right? So since my products are powering all the Copilot services, I took the liberty to say Microsoft Copilot. Now, Copilot, I think our marketing team hit a home run with the branding of Copilot. Because what Copilot does is perfectly encapsulates what the potential of AI is to help all of us. But at the same time, it leaves all of us in control, right? So Copilot is a goose. We get to be Tom Cruise. We get to be Maverick. We have complete control over how AI is going to help each and every one of us. All right, so with that out of the way, I wanted to start with a little bit of a framework, because yesterday in Satya's keynote, you heard him talk about Microsoft optimizing on every layer of the AI software stack, or AI stack. What I'm going to be focusing on is at the bottom, at the base, what empowers all the services that Microsoft provides. That's the data center infrastructure. So we're going to be talking about servers, we're going to be talking about cooling systems, network racks, as well as storage, and as well as compute. That's where we're going to be focusing on today. So the other thing that you're going to notice is that a lot of the Microsoft employees, when you see them, they look a little tired. And the reason for that is because we've been on this incredible torrid pace. Ever since November of 2022, right? Ever since the launch of ChatGPT, AI has really been changed, right? And Microsoft has been preparing for this moment. Satya has made sure that the entire organization has been prepared for this moment. And in a little over 6 months, we had taken that technology and made it available to our customers as Copilot services. Incredible speed with which we're moving. Then at Build this year, in May of this year, Satya was on stage indicating that over 50,000 organizations have already been trialing or planning to launch Copilot services into their business. Again, an incredible, incredible pace. So what is driving this pace of innovation? Because to be honest with you, artificial intelligence has been around for quite a long time, right? Okay. What is transformative about what we're going through right now is really generative AI, okay, which has been perfectly exemplified by the launch of ChatGPT. It's this insatiable desire or need to have more powerful and massive models. And coming from high-performance computing and HPC space, I can tell you AI is a perfect app for this workload. It's a perfect workload for high-performance computing because it's directly linearly scalable. More compute you can throw at this, the faster you're going to solve the problem. More massive the problem is, better it can scale. And why do we need more powerful models? Well, think about it, right? We were all blown away when we had ChatGPT. We were willing to live with a little bit of a delay. You know, you would put a little prompt, and it would take you a few seconds for the answers to come back. In fact, around Valentine's time, I actually had the ChatGPT write a love poem for my wife because I'm not much of a poet, all right? And you know, I was able to get some brownie points with my wife for Valentine's Day. But people are not satisfied with that anymore, right? Have everybody seen Sora? Okay, which is an application that OpenAI launched, which allows you, just with a simple prompt, it's able to generate a high-definition video that could have been probably done by Pixar 5-6 years ago. This change of innovation that is happening in the AI space is amazing. And the consumer's demand and enterprises' demand on how we can utilize that technology and tool is also insatiable. So this change, this transformation of these models to be more performant, to be multimodal, multitasking, that is what is driving this incredible growth. And soon, people are going to expect this thing to be interactive, real time, so as if they're having a conversation with an individual. All that is enabled by infrastructure, by compute power. And that is what you're seeing on the graph on the right-hand side. What you're seeing on the blue line is like recommendation engine, other types of AI models that have, that have existed for a long time. What you're seeing on the red is the large language models, the frontier models. And it is growing at a rapid, rapid pace. It doesn't take much. Just take a look at a tweet from Elon Musk, what he was doing with xAI. That is the race of this generation. So, wonderful technology has been around before in our history, but the technology that seems to take hold and transform how we live are technologies that have impact to every people. It's pervasive, right? So generative AI is that pervasive technology that's going to transform the world. Satya on the keynote yesterday talked about many different organizations that are taking generative AI and making it useful for their business. I just took two elements here. On the left-hand side are the developers, because developers are going to power on the next services that's going to transform the world, right? So what you're looking at there is that with GitHub Copilot, you have not only faster developers, but happier developers. They're able to do their job 55% faster, and they say they're more fulfilled 60 to 75%. Okay? It's really about enabling individuals' capacity, individuals' capability, and making us the best version of ourselves through this technology. On the right-hand side is how it's being utilized from a marketing perspective. Synthetic marketing, we've all seen this, right? A lot of the marketing stuff that's coming to us, we know it wasn't created by humans. So right now, if in 2022, about 2% of that synthetic marketing is done synthetically, it is estimated by 2025, and I think that's a relatively conservative estimate, over 30% will be done by AI. Another data point that I want you to think about, most of the data that we have today has been created in the last 10, 15 years. Imagine how much more data is going to be available in the next 5 to 10 years when it's so much easier for each and every one of us to create new content, create new data. So that tells you what kind of world that's waiting for us. So then I want to talk a little bit about, if that is the macro condition on which we're seeing this AI transforming the world, how has the infrastructure industry responded to that demand? So what I wanted to do is juxtapose that. So on the left-hand side, again, you're seeing that incredible growth, incredible demand. And on the right-hand side, I kind of bucketize the infrastructure into three segments. How the infrastructure is responding to that incredible demand and then growth and that change. One is about being faster and more. And here, what I want to highlight is NVIDIA, who's clearly been the leader when it comes to AI in terms of creating compute, the infrastructure that's necessary to advance the state of AI, They're releasing a new product every year. They're a silicon company. As I mentioned, I worked at Intel, right? Intel was moving very much in a kind of a silicon pace, which is really about tick-tock model, 2 years, single platform, lasts for 2 generations of products. That has been turned upside down, right? And they're setting the pace right now. And the competition is trying to lock into that pace that they're doing. What that means is we have new technologies that's being made available all the time, okay? So again, expect that explosion of new products that's going to be coming out to the market, and expect explosion of innovation that's coming into the infrastructure space. You just need to go out to the hub that's at the center to see all the infrastructure innovation that Microsoft is doing. But it's not just Microsoft. There are other infrastructure providers that are doing that level of innovation as well. In the middle is AI innovation. So one of the things that I like to tell people that I know is the most expensive real estate is not Tokyo or Manhattan. It's the surface space on a silicon, okay? And then companies make decisions on what gets on that real estate. And if you take a look at the NVIDIA's GPUs over time, AI features have been dominating that expensive real estate. So what that means is things like mixed precision, okay? Those types of AI-enhanced capabilities will continue to be imbued into these new infrastructure products. The other thing that I want to talk about is new SoC architecture, system-on-chip architecture. Okay? The GB200, the Blackwell generation product that Satya mentioned, will be in preview at Azure for the very first time. That is not just GPU. That is a platform that has a Gray CPU connected to a Blackwell GPU with NV-switch chips that are now able to create GPU pod size greater than what was done before within a single server, and now it's able to connect to multiple servers and provide even larger GPU pod capability, which enables AI innovators like OpenAI to be able to bring new frontier models faster to the market. That is the amazing thing that is happening in the infrastructure space today. So this is a very busy slide, but one of the things that I wanted everybody here to understand is that you don't become a supercomputing company overnight. It is a muscle that you need to develop over many, many years. It took Cray many decades to become synonymous with supercomputers. And Azure had the foresight to invest in this supercomputing capability over many years. So I'm just going to highlight a few of them. And a couple of common things you're going to hear is scale and performance. And first in cloud is what you're going to be hearing. And when I talk about scale, I want to make a distinction, because people can talk about scale all the time. In supercomputing, in AI specifically, what you're looking for is synchronized scale. What that means is the ability to scale a single job across large number of nodes working synchronously to solve a single problem. That is a much, much harder problem than to be able to scale single node jobs across large number of nodes. So starting with 2019, Azure was the first to launch a 20,000 cores MPI job. MPI stands for Message Pass Interface. That's how you parallelize a single application across multiple parallel computers. And in 2020, we quadrupled it to 80,000 cores, 12 times more than any other cloud provider at that time. And in 2021, we delivered, actually several years before, a top 5 scale supercomputer to OpenAI. And this is the supercomputer that was used to train ChatGPT. And in 2022, we submitted a MLPerf submission. MLPerf is like a de facto standard benchmarks that's used to measure the efficacy of a supercomputer one from one another by being able to run the same benchmarks. We landed #1 in the cloud and #2 overall. And last year, we reran that test, and we were able to again achieve #1 and #2 overall. And not only that, we were able to list a top 3 supercomputer in the top 500 benchmark, and I'll talk a little bit more about the top 500 benchmark, which was a first in the history of high-performance computing. We're super proud of that. And just this year, we're continuing the same pace. We were the first cloud provider to submit a H200, which is a second-generation Hopper product from NVIDIA, and be able to launch a 512 GPU run. and be able to get on the MLPerf ranking list again as well. So again, you're seeing this trajectory of Azure continuing to make investment in this space so that we would be able to optimize, okay, and be leaders in that layer of our overall AI stack. So touching a little bit about the top 500 list. So top 500 list is an annual list that comes out twice a year, okay, in June in Germany, and then November, typically in the United States. This lists the top 500 of the most powerful supercomputers in the world. This is primarily used for high-performance computing and modeling and simulation. We were the first cloud provider in the history of HPC to have a top 5 supercomputer. We did this in November of last year, and we were able to continue that in June of 2024. And in full transparency, the new November list came out 2 days ago, and we did lose our number 3 spot. We went to number 4. But that's not the important thing. The important thing is Mark Russinovich, who's our CTO for Azure, back at Build said, hey, everybody knows about us landing a number 3 supercomputer. Did you know that since November to May at the time, we've already shipped 30 times that capacity to Azure? So if we are able to run HPL Impact on all of those machines, we would blow that number 1 clearly out of the water. But obviously, just running benchmarks is not what we do, right? We want to make these capabilities available to our customers. But again, I want to share that with you, just for you to kind of grasp the sheer audacity and the scale that Azure is working with here. What enables that type of supercomputing capability is the incredible amount of innovation that is happening in our space, in the infrastructure layer. And and when I say infrastructure, I want to make sure that everybody understands it's really all about building data centers for this new AI world, as well as building custom silicons and everything in between to make that possible. But instead of me talking to you about all the creative innovation things that we're doing, I'm going to invite Zaid to come on stage, who's our VP that's responsible for our architecture team, to talk about some of these infrastructure innovation.
Thank you very much. John talked about some very, very important things about how we think about building and scaling supercomputers. So before I go into sort of, what I want to cover is basically to give you all an idea of like what goes on in the challenges, right, that we are facing as we're building these very, very massive scale supercomputers, and how we are actually innovating in that space. But I just wanted to step back a little bit to what John was saying earlier, which is like when you think about supercomputers, it's not like the single node, it's like really how they are stitched together. And what's very interesting is when, one of the very core components of supercomputer design is what we call hardware-software co-design, which is we work with our model developers very, very closely as we're building out this supercomputer. It's not like, go build this, hardware and I'll come in like run my stuff over it. No, it doesn't. That's the old way of developing, right? On x86 platforms, we don't do that now. They're very tightly coupled. What we find is that the developers are saying, hey, to get the maximum performance, we want this concept of a pod, which means basically that n number of GPUs, like you've heard, like 72 now, and it's 36. They are tightly stitched together. In the NVIDIA world, it's via NVLink. You can do it over Ethernet. You can do multiples, but they're tightly switched together under one tier of switching, which means that you don't actually go out into the network inside the data center. You try to maximize your performance in there. So what does that do, right? Before I get into sort of the slides, I wanted to show you what that does is basically really create some very, very interesting challenges. So one is when you stack all of these, or stitch all of these GPUs into a rack, there's enormous amount of cooling because these chips are hot, that a lot of cooling comes into play. And so, liquid cooling becomes like super essential, right? Now we've maximized the amount of air cooling we can do in traditional data centers, but we're finding that GPUs are trending over 1 kilowatt, right, per chip. So when you stitch all of these up, you're looking at like, over 100 kW in some cases, right? The way it's trending. And that is enormous amount of power in a particular rack, and it takes an enormous amount of cooling. I generally find that when you get to like 750 kW per chip, after that you really got to cool it, otherwise the chips become like super hot. So stepping back, right, what are we doing at Microsoft, right? First is we are realizing this way ahead, and we're building out data centers that will have facility water cooling, which means they'll have chillers and they'll have a dual loop system, and they'll basically will bring water to these chips to cool them. And so that's what we're building towards. But there's also a lot of data centers we still have in place that that capacity is needed to sort of fill this demand that is growing, as you've seen, right, in the earlier slides. The amount of growth for models year over year is 4x or something, right? Like it's a huge amount, and the hardware is actually trying to keep up. We are still like, it's not matching. Like the software people would actually love it a little bit faster, right? But the pace of the industry in hardware, even though we're producing chips year over year, that's still like we're still trying to catch up, right? So basically, what that means is that we now need in the rack system, more cooling, more innovation in the cooling space, because while we're still building out facility water cooling, there's many air-cooled data centers we need to build. So cooling distribution units, or CDUs, are sort of now becoming a very essential part of deploying this large-scale supercomputing infrastructure. And then overall, we at Microsoft are thinking about what is in the future. If this trend keeps going, which we see there, then you'll have to do more innovation, right? And so the couple of things we're looking at is when there's cold plates on these chips, generally today there's just one way of the water coming in and cooling the entire chip. We're also finding that with HBM memories getting hotter and other components in there, we may need to create this concept of zonal cold plates. So we're actively looking at multiple directions that water can come and cool this chip. The other one is we want to go one step further. We want to bring cooling at the silicon level, which is a harder problem, but there's this amazing amount of research being done in Microsoft on microfluidics, and that's an area where we'll keep investing so we can start to cool down at that level, right? So overall, like what keeps a lot of us up at night is cooling, right? That is like the one of the big things. Power is the other one, which I'll talk about later, right? So what are we doing in innovation? So actually, we designed, and then Satya talked about this in his keynote, we designed a new liquid heat exchanger, and this can cool up to 144 kW per unit across our data centers. And we designed it so that it's super flexible. It can deploy in any of our air-cooled data center facilities. It has multiple hot swap components, like you can multiple pumps, N+2 redundancy, lots of fans that are redundant, filters and sensors, and all these things that make sure that all we can cool each of these racks, right? And at OCP this year, Open Compute Platform, it's a foundation where we actually work with the open source community in hardware. We announced that we'll actually be contributing this to as a next generation of our liquid cooling heat exchange to the entire community, so that other people can kind of build a standard. We can hopefully build a standard around this as so we can solve this problem in the industry as well. And we designed this with our key partners, Delta and Invisys, and it basically, when you think about it at a high level, it leverages the same temperature and airflow that legacy data centers have. So we don't change anything in the data center, right? And they're used in regular air-cooled platforms. We designed this to support whether it's NVIDIA, whether it's a Maya chip, or any other accelerators that come by. And so that makes it like a very universal solution for us. The heat exchanging unit is also an evolution of our former Sidekick program, which you heard, I think last year at Ignite was announced. So we keep continuously building out a new generation of this. And this has 5 times more the cooling capacity than what we had built in the 𝗦𝗽𝗲 generation, first generation. The design is really further optimized for airflow efficiency, lower power consumption, resiliency, and able to sort of scale in hyperscale environments with sort of an end-to-end perspective. Think of it like a platform, right? It's not just a regular heat exchange in 8 ways like a radiator, and you're doing that. There's much more to it, right? And so that's a key thing, and we're very proud that we're open sourcing this this year, which was I think we just open sourced it in October, so September, October. Anyway, so now what's the next sort of big challenge, right? Is power. Right, you heard John talk a lot about how it is, these chips are becoming hotter, and every year, NVIDIA takes out yet another chip, and it's amazing to see that the TDP of this just keeps growing, right? So what's happening, right? Like first, let's think about it at the data center level. The picture on my left here is just of how data, like large scale data centers that are out there, right? And at the DC level, the high energy demand is just increasing, right? Like if you step back, if you think about data center capacity, well, the demand will double by 2026, right? That's only a 4-year period. That has never happened in general compute. Like it's very predictable, and you can say that, hey, this will generation over generation go. This is unprecedented, right? And so what really consumes? What are the big drivers, right? The big drivers is the high energy consumption that AI computing brings. So we can think about it as 40% of that, of all your data center power is just taken up by the high performance computing, and then the 40%, because you're trying to cool this thing, right? And if you think about it, right, I was just kind of reflecting back when I've been building data centers and systems for a very long time. And prior, we were just looking at, hey, we're going to grow this 20 megawatts, go to 100 megawatts in X number of years. Now we're talking at gigawatt scale, right? If you just look at the news, there's so much talk about like gigawatt rate data centers, and that's just where it's going. And those are just from very, very massive numbers, even from a power and utility perspective, right? Now on the right here, is the rack, right? Now the rack, how does that translate to the rack? At rack level, if you were designing compute systems back, like in 2020 or even 2019, you were probably, reaching 20 kilowatts per rack, and you could say like, I can do this. Now we are already at more than 100 kilowatt per rack. That is an amazing. I mean, that's just like it just burst up, right? And we have, we're thinking now of the power challenge, the power problem that comes now to the rack. Now, how do you actually effectively power 100 kW, into a rack? And so that is one of the things. The other thing that sort of keeps us up at night, right? How do you sort of make sure that you're effectively, delivering the right power, because these chips are continuously going. So we've noticed this change over time. We've been observing it and keeping tab of it. And prior, most of the power in the GPU compute rack was all in one rack. We packed everything together. But now the trend is that we want to pack more and more GPUs. Remember, I told you they need to be all stitched together in these super high pods. Well, developers are telling, we want these pods to be bigger, right? So what that means is basically that we're looking at, over the next 2 to 3 years, racks that'll scale potentially up to 1 megawatt. So one of the things that we've been trying to do on the architecture and design side is basically think about how do we disaggregate the power from the rack, because it's getting to that point where they don't coexist well together, right? In the same rack, and we're just tightening a lot of things, trying to fit, so many, kind of those Lego boxes that eventually it starts to like get out, right? So we went into And this is a really interesting problem because it's not just a problem for Microsoft. It's a problem that other CSPs and community faces. So we do a lot of collaboration with Meta at Open Compute, and so we collaborated with Meta on figuring out how to solve this power problem by disaggregating the power from the rack. So we created a 400 volt DC standard. So the power is now not in the main rack, but is in a separate rack. And you're able to now create up to 35% space in your primary IT rack and have more GPUs there and segregate this thing. And instead of many cables, we use this bus bar concept, and it's all sort of seamless. This sort of lets us scale up to like the megawatt rack that could be down the road, and also like the whole point is that now it becomes like a super modular design. Like you can scale your IT rack separately, you can scale your power rack separately, and you can even scale, the next generation of all of that. And so this 𝗦𝗲𝗶𝗸𝗀 power rack is our latest contribution. And just to sort of close, I've shared sort of like 2 ways where Microsoft is innovating in AI infrastructure and system design. And we need modularity and innovation at every level to solve our infrastructure challenges, and cooling and power delivery is one of them. And so I'm very happy to sort of share this with you, and happy to take questions later or come by our booth. And actually, if you come by our booth later, just a little plug, you will see the cooling unit, and we can walk you through like how it is. So thank you very much.
Thank you, Zaid. So all the infrastructure innovation that Zaid talked about is what's powering all the Copilot services that our customers are consuming today. So things like Security Copilot, Microsoft 365, Dynamics 365. These are all services that are running on top of these innovative infrastructure solutions. Now I'm going to drill into the VM layer. So this would be customers like Walmart who uses our VMs not only to run their businesses, but also to develop their own custom language models, whether they are small, medium, or large, and then be able to deploy those inference services throughout the world. And those services run on top of different types of VMs. It's really important to note that there is no one-size-fits-all when it comes to AI. A platform that you use, a GPU platform that you use to train your model may be very different than the infrastructure or the VMs that you infer that service on. And the reason for it is very simple, because you're going from a research model to an applied model. And cost of goods sold becomes really important as you scale these inference machines apart. So on the bottom layer is what you're seeing in terms of what Azure is offering for our VM services and VM capabilities. We have optimized VMs for real-time inference and low-cost compute. We have one for mid-range training and dense inference. And we have one that's for distributed training and generative inferencing. And this is really important for you as a customer, because making the right choice means you're going to get better value from that. So yes, can you use Porsches to commute to work? Yeah, but it's a heck of a lot more expensive, right? Okay, if you're taking your family to a camping trip, you don't want to be taking 3 Porsches. You take a minivan, right? So making that right product choice is going to make a huge difference in the business that you're going to run. So this is an opportunity where I wanted to kind of share with you how we're looking at the AI landscape in the forms of training and inference, and what ChatGPT has introduced into the world with this generative inferencing. So I wanted to talk a little bit about that. Starting from the left, so training. So training this is the one that everybody talks about or wants to talk about, because this is the massively scalable supercomputer that you need to train that next large language model. So this is what OpenAI uses to go from GPT-3 to 3.5 to 4, and in the future, 5. As well as the reasoning model that they recently released with the 𝗦𝗲𝗀. That is what everybody focuses on, okay? But you don't need too many of these training supercomputers, right? Because there are only a few innovators in the world that can do something like that, right? And then on the other side is discriminative inferencing. So discriminative inferencing is what you and I, all of us as consumers, have experienced for many, many years. So this is when we go to Netflix, based on our watching patterns before. They did batch inferencing the night before, so when you log in the next morning, it has miraculously recommended 5 or 6 other movies that they think you're going to like based on what you've watched in the past. This is what Amazon uses, right? Based on the purchasing pattern that you've had, it makes recommendation, hey, you may like this. But the problem with discriminative inferencing is there aren't too many organizations in the world that can actually commercialize that. Unless you're an Amazon or a Walmart or a Netflix, right? There aren't that many organizations, so it's not applicable, it's not pervasive. What's different about generative inferencing is not simply having a model and then making predictions. It's actually creating new content. So it's creating new stories. It's creating new video. It's creating new images. And there's incredible power as well as incredible applicability to every business. Because what business do you know that would not benefit from higher intelligence or better intelligence? That is what is amazing about generative inferencing. And the important thing here is for training, for discriminative inferencing, and for generative inferencing, you need different optimized hardware and VMs. And that is where our team is focused on to make sure we're making the right decisions in building infrastructure solutions for customers that want to train, that wants to discriminative inference or to generative inference. So I want to talk a little bit more about that and just bucketize into two things: training supercomputers and inferencing machines. Training supercomputer is not just about GPUs, even though I know Jensen loves to talk about GPUs at the center of everything. That is true. GPU is doing most of the heavy lift. But in order for you to have a productive supercomputer, you need to have a system solution, end-to-end system solution, that provides complex workflow between the CPU, the GPU, as well as storage. And you don't need too many of these. And not many enterprises can really take advantage of that. Majority of the enterprises that we work with want to take an existing models and just simply customize it for their own specific use. That doesn't necessarily require a supercomputer. Inferencing, on the other hand, is very different. Inferencing is all, and generative inferencing, it's really about taking that pre-trained model and then being able to offer that as a service globally. So what that means is the type of product, type of infrastructure that you're going to need for that is vastly different. So Satya said we have over 60 plus Azure regions, over 300 data centers in the world. The reason why we need a heat exchange unit, right, the next generation sidekick that Zay talked about, is because these data centers already exist. We have to be able to fit these new IT infrastructure into those existing data centers. The new ones we're building, we can build it to customize it for an IT equipment that's able to drive 150, 200 kilowatts. But what do we do with the older ones, right? So that sidekick, the next generation sidekick, is really about being able to put the new IT equipment into those existing data centers. So let's focus on training supercomputer a little bit, because everybody's focused on having lots of GPUs. But guess what? You need an associated CPUs. And why do you need the CPUs for? It's really for things like pre and post-training data processing. Garbage in, garbage out. You got to do a lot of work to prepare the data so that the GPU can actually utilize them efficiently. You're crawling the internet and downloading new data all the time, raw data. Where is all that raw data going to go? It needs to go into some kind of a storage. And where the storage is located, where this pre-post processing is happening, and where the GPU training is going to be happening, there is potentially a proximity need. Amount of bandwidth, latency, sensitive, data locality, these are all issues that you need to think about. So that's what you need to do when you're building a very large, effective training supercomputer. Inferencing is different. Now, generative inferencing has there's two phases to a generative inferencing. So we just finished Olympics in France this year, right? So training, you can kind of think of it as a synchronized swimming at a massive scale. Everything has to happen in a synchronized mode, and that puts very demanding pressures on the infrastructure, on power and cooling. We literally get phone calls from the utility company when we're powering up our supercomputer because it makes a huge blip because of the synchronized nature of the workflow. Inferencing is different. Inferencing is like water polo. There's two elements to inferencing. There's a prompt phase, and then there's a response phase, right? So one is very memory intensive, and one is very compute intensive. Okay? Not only that, those infrastructure, as I mentioned before, it needs to be where the people are, where all the data centers are located. As you can see, here are all the data centers that Azure has. If we want to make Copilot services available to everybody, well, we need to have those IT equipments everywhere. That's what the generative inferencing IT infrastructure needs to be optimized for. So two distinct architecture. And then when you look at that from a VM layer, as I mentioned before, I bucketize between discriminative inferencing, generative inferencing, and training. That's what our product, VM products, then become. So you as a consumer, when you are thinking about supporting your organization and trying to decide, hey, I need to take an existing meta model or an OpenAI model, and I need to feed it my proprietary data and make it uniquely applicable for my business, then you're going to want to do that on an ND series. Okay? If you already have an existing model and you simply want to be able to release inference fleet, type of inferencing that you're going to dictate whether you're going to use an NC series on the T4 or the types of like H100v5 or the A100v5. So these are different fleet of AI VMs that's available in Azure that you'll be able to take advantage of. And if you ever have any questions about what you should be using, please reach out to our architecture team, our GBBs, as well as the product organization, and we'll be happy to walk you through, tell you the pros and cons of using these VMs. Especially the ND series are on pretty high allocation right now, which is why it's super important for us to make sure that you have more choices. That's where things like our partnership with AMD, strategic partnership with AMD, is super important, because we want to make sure that you have choices, right? You don't want to go into an ice cream shop and only thing they have is vanilla, right? You want to have choices. That's where Maya also comes in as well, right? We want to make sure that we're providing the flexibility and choice so that you can make the right decision for your enterprise. This is an eye chart, but for every one of these numerical numbers, our product managers had to like sift through huge amounts of data to make the right decisions for that specific VM product, okay? And I tell my product managers all the time that roadmap complexity is like product managers' job security. And our friends at AMD and NVIDIA has made our life a lot more difficult because they're coming out with some really cool stuff. And at Microsoft, we can't do everything. We would love to be able to do everything, but we can't. So we have to make all these tough decisions by looking at all these data and making decisions. And that's what these products here come out to be. And I want to kind of close by sharing with you the most recent announcement, right? This was an announcement that Satya made yesterday, okay? So here's a little video that's coming.
As generative AI continues to change the face of industry, Microsoft and NVIDIA are forging a new path of innovation and redefining what AI can do for everyone. Microsoft brings the new NVIDIA Blackwell platform to the cloud, combining the NVIDIA GB200 NVL rack design and NVIDIA Quantum InfiniBand networking to power purpose-built Azure instances that deliver groundbreaking performance for AI workloads. Microsoft infuses innovation at every layer, from our advanced liquid cooling sidekick to technology that boosts and optimizes server processes to security at the hardware level, all enabling optimal performance for the Blackwell platform on Azure to accelerate state-of-the-art generative AI. From turning simple prompts into complex software to transforming intractable questions into historic breakthroughs, generative AI has taken its place at the forefront of human discovery. Together, Microsoft and NVIDIA are powering the AI innovation that empowers greater human invention.
Thank you so much. So our product team is obviously very excited about the announcement of Blackwell on preview on Azure. And the Blackwell generation actually introduces some really step function improvement in performance because of its ability to support mixed precision, lower precision math, as well as off-chip capability. Specifically, the ability to expand NVLink, which was limited to the domain of a single server, to multiple servers. Zay talked a little bit about GPU pods, how it was like 8 GPU pods. Well, that potentially could go up to 72 GPU pods with this generation of product. And that is a step function improvement in performance that's going to provide innovators like OpenAI, as well as Microsoft and Meta, new capability to be able to push the boundaries of what's possible with our next frontier models, which in turn will translate to amazing capabilities that's going to be available to each and every one of us through Copilot services and other services. So we're super, super excited about this. And that's my second to last slide. My last slide here is simply just inviting all of you to learn more We have several sessions tomorrow where you get to learn more about our infrastructure and how we're utilizing that infrastructure to support your business. And also, as Zaid said, Zaid and I will be at the expert meetup in the booth in the hub section. Okay, come and look for us. I'm actually hosting an Ignite roundtable. I think it's all sold out, but you're more than welcome to hang out and just kind of listen in, where we get to play a little game of Uno. I wasn't the one who chose the game. I don't even know how to play Uno, but I'll figure it out by tomorrow. And also talk about infrastructure, power and cooling. So if you get excited about infrastructure like I do and Zaid do, please come and see us. Thank you so much.